Hey guys, so we're gonna do 2013 for response number 3. All right, it's obviously written on the board back there. This is non-calculator. Remember, only use a calculator for numbers 1 and 2. 3 through 6 is all gonna be non-calculator. So here we got a table. We got hot water is dripping through a coffee maker, filling a large cup with coffee. The Red Bull sounds a little bit better to me. The amount of coffee in the cup at time t from 0 to 6, so we're going to be including those boundaries, is given by a differentiable function c. Okay, so that's going to be important later on in this problem, where t is measured in minutes. Selected values of CT measured in ounces are given in the table above. All right, lots of fun information there. Let's just get on to part A. So use the data in the table to approximate C prime of 3.5, show the computations that lead to your answer and indicate units of measure. All right, so we need to approximate C prime of 3.5. Now guys, we can't find the exact value of 3.5 because we don't have an equation. Okay, we need an equation, then you can find the exact value. Here we're going to need to approximate it. Alright, so what we're going to do is just use AROC. So 3.5 is going to be in between 3 and 4. So we're going to use our data from points 3 and 4. So this is going to be C of 4 minus C of 3, all divided by 4 minus 3. Alright, so what we're going to do now is just figure out what that is. So we got 12.8 minus 11.2, all divided by 4 minus 3. Now guys, I would just stop right there. You don't need to do any further. Okay? It does ask us to indicate units of measure. Yep, so we don't have to explain what this represents. It's not asking any of that, just come up with our units. So look back here, my units on top were C, and C is measured in ounces. So put a little OZ if you would like. On the bottom here, we got our time. Our time is measured in minutes. Okay. If you were to work this out, it's going to come out to 1.6 ounces per minute. All right, but we want you to stop here because you might screw that up because your algebra is so outstanding. All right, so let's move on to part B, shall we? Part B, is there a time t between 2 and 4 at which C prime equals 2? Justify your answer. Okay? So this is what I was saying before, guys. It's asking you, is there ever a time where C prime of t is going to equal 2? Is there ever a derivative that's going to equal 2? Okay, that's going to be kind of your clue to use MVT. Versus the difference if it just said, is there ever a C of t that's going to equal, well, we could say like 14, okay? Here it would be having to happen between 5 and 6 because going from 13.8 to 14.5, you'd have to cross through 14. Okay, but this is a derivative. So we want to use MVT. Okay, so the first thing I would always do on this is just jump straight into IROC equals AROC because that gets you your guaranteed point. Okay, it's going to be all that justification that's going to get you your other point, which is going to be harder to get. Maybe you guys want to write that down on your note sheet for this year. Okay, maybe some kind of clues on how to explain IVT and MVT and all that fun stuff. So I'm just going to look at this. So we're going, our interval was 2 to 4. I believe, yep, from 2 to 4. So I'm just going to figure out, well, C of 4 minus C of 2 all over 4 minus 2. Okay, that's going to equal 12.8 minus 8.8 all over 2. So this is going to be 4 over 2, which equals 2. Okay, so guys, if you ever have to do MVT, the first thing I would go with is our end boundaries. Okay, if that doesn't work, that doesn't necessarily mean that it's not going to work. I would then check 2 to 3, and then 3 to 4, and hopefully one of those will be working for you. Okay, but always start with your largest one here. So it is true IROC is going to have to equal AROC, but now we need to justify all of this. Okay, if you look back up into those directions, or whatever you want to call that, is given by a differentiable function c. Okay, so we want to say c is differentiable on our closed interval 0 to 6, therefore continuous on the open interval 2 to 6. Alright, so if it's differentiable and continuous...
Other way, Ernie. Differentiable on the open interval, continuous on the closed interval.
We can just use both closed, can't we?
Not supposed to.
Let me look at this. Is given by differentiable function c. So let's say
It
c.
can't be differentiable at an endpoint because you're not differentiable on both sides. That's why it's got to be parentheses.
Fine. Probably be okay on your test, guys. Don't worry. C is differentiable on the open interval, therefore continuous on the closed interval, and MVT holds true. Okay, so basically you have to say it's differentiable, therefore continuous, because MVT needs both of those for MVT to work. And then you just need to talk about, well, MVT is going to work then because it's differentiable and continuous. Okay, you already did all of your algebra work here. So, there must exist a t between, our interval was going to be 2 to 4, such that, okay, our derivative, c prime of t, is going to equal 2. Okay? So this is like your hypothesis statement, and you just need to say, well, there must exist, basically restating what they asked you already. Because if you look at those wording, is there a time t between 2 and 4 at which c prime equals 2? Well, you're just saying, well, yeah, it works out because MVT. All right? That will get you all your points there. So let's move on to part C. Use a midpoints sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1 over 6 integral from 0 to 6 c of t dt. Using correct units and explain what that is in the context of this problem. Guys, so let's go over here, part C. We need to estimate 1 over 6 integral from 0 to 6 c of t dt. Okay, so hopefully you guys recognize this is just going to be fave. Okay, because our interval is from 0 to 6, and we have a 1 over 6 out front. And now we're going to estimate this by using the midpoints. Okay, we haven't done midpoints for a little while. So, 3 subintervals is going to look a little something like that. So remember, we're going to want to use the middle value on every one of these. Okay, each one of these bases is going to be 2. Okay, but we're going to use the heights that are in the middle. Kind of just like that. All right, so make sure you keep your 1 over 6 out front. And guys, make sure you understand that what we're doing with our midpoint sum is approximating the integral from 0 to 6 of c of t dt. Okay, because I had somebody on your homework that said they were integrating like the rectangles. Don't do that. This is approximating our 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8. Okay, this is approximating that integral. We're going to multiply that approximation by 1 over 6. Okay, and stop there. Don't keep going. Okay, this is non-calculator, but even if it was a calculator, there's no reason to type that into your calculator. Let's see what. Let's just reread this. I know we got to explain using correct units. I want to make sure we did everything. Using midpoint sum with 3 subintervals, so we did that. Approximate 1/6, so we did that. Using the correct units, explain the meaning in the context of this problem. Okay, so the units of this, understand, are going to be the same units as C of t. Okay? Understand that if you integrate, this is some scratch work, if you integrate C dt, okay, so C was ounces. If you integrate ounces with respect to time, you now have ounces times minutes, which doesn't make a lot of sense. But then we're going to multiply by 1 over time out front. So what happens is your minutes cancel, and our units are now just going to be ounces. So we don't really care what that number is, all right, but the answer is in ounces. So what this is going to represent is 1 over 6, integral from 0 to 6, c of t dt, represents the average amount of coffee so many words in, I believe it's a cup. Yep, from a large cup, in cup. So this represents the average amount of coffee in cup in ounces for the 6 minutes interval. Okay, lots of different ways you can word that. I believe when I went through it earlier, I probably worded it a little bit better. I think I said it represents the average ounces of coffee in the cup for the 6 minute interval. I think that sounds a little bit better, but it's really saying the same thing.
Nice.
Last one, part D. All right. The amount of coffee in the cup in ounces is modeled by an equation now. Using this model, find the rate at which the amount of coffee in the cup is changing when t is 5. Okay, well, if our equation B of t is the coffee in the cup, and we want to figure out what's the rate of change at 5, we just want to find the derivative and then plug 5 into our derivative. So, let's just write down B of t is going to equal 16 minus 16 e to negative 0.4 t. Okay, so just make sure you take the derivative correctly. So I want to find b prime of t. Okay, so derivative of 16 will derivative of a constant 0. Over here, I'm going to have a negative 16 times e to negative 0.4 t times the derivative of the inside. So the derivative of negative 0.4 t is negative 0.4. Okay, guys, I wouldn't even clean it up. I would just leave it exactly like that. Then they want you to approximate or find what b prime of 5 is. Literally just plug it in. Don't even simplify a thing. Okay, so I'm going to leave this as negative 16 e to negative 0.4 times 5. All of that times negative 0.4. Can't stop. The only thing that's going to happen if you keep going is you could lose points. You're not going to get any bonus points. All right.
There's no bonus points on the AP exam,
No
Mr. Hurley?
bonus points for simplifying completely.
Oh.
So, let's go ahead and talk about our points. So, part A was 2 points. You get 1 point for your answer. Okay, you didn't need to get 1.6. You could have this one or this one. You got to show some kind of work. Okay. You get another point for your answer of units. So our units were ounces per minute. You could spell it all out. If you didn't know ounces was OZ, that's all you got to do. Okay, part B is also going to be 2 points. Okay, I think I kind of alluded to you get 1 point for doing MVT. Okay, IROC equals AROC. All you got to do is AROC, showing that it's going to equal 2. That gets you 1 point. You don't have to have any words with that. You get your other point from all of this. Okay, it's going to be very particular. Right? You have to talk about differentiable and continuous on the intervals. Therefore, MVT is going to work. And then you have to go and just restate the conclusion here. Okay, so there must exist a t between 2 and 4 such that c prime is going to equal 2. All this garbage is going to get you 1 points. Okay, on this problem, make sure you get that AROC point. Okay, that's going to be your easy points. Overachievers can go for that extra one. Part C is going to be worth 3 points. Okay, basically you get 1 point for using a midpoint sum. You get another point if you had the 1/6 with your midpoint sum. Okay, you don't need to simplify anything. Just leave it like that. That gets you right here. This one single line got me 2 points. Okay, you're gonna get your third point from explaining what the heck you're talking about here. So it's the average amount of coffee in ounces for the 6-minute interval. Okay, make sure you're including those units in both of those kind of spots there. Part D is going to be worth 2 points. You get 1 point for B prime, and you're going to get 1 point for plugging 5 in. Guys, if you get B prime, and that's the easiest point in the world. You just replace all of your T's with a 5, and you don't have to reduce. You're done. Yeah. I'm sure glad I didn't have to do that part D, whatever, 2018. That was gross.